I'm a licensed general contractor in California, and we specialize in soft story seismic retrofitting. And my main goal for anyone that is looking to start retrofitting is education. This is a really new process for most property owners, and we do our best to, take the stress off of worrying that you're going to end up having to do engineering twice, which happens quite often, honestly, and, pick a contractor that's going to do a good job, show up at that site every day, and, not leave for months at a time. Starting off, what is retrofitting? So the word retrofit is to add an element to something that wasn't there when it was manufactured. So seismic retrofitting, we're adding lateral elements to the building that were not there when the building was built. So starting off looking at past earthquakes, in 1906, 80% of the population was left homeless due to building collapse and fire. And then 50 years later, the Kern County earthquake had $60 million in property damage. And the Ridgecrest earthquake, which happened last July, was a 7.1, was 100 miles from here. And if that 7.1 would have hit closer to downtown Los Angeles, we would have seen a huge catastrophe, but most of the buildings out there were built after the 90s. So the next earthquake would be in 1971. In the San Fernando earthquake, they had many hospitals and overpasses that collapsed. And this really created a catalyst for changing the building code for new construction. So in 1978, the building code was changed to add lateral elements to all new construction. And they also began retrofitting government buildings and overpasses at that time. So in 1989, when the Loma Prieta earthquake struck in Northern California, we actually saw what the retrofitting of the government buildings did. And there were some failures, so they kept progressing and changing their engineering of retrofitting. And by 94, when the Northridge earthquake hit, about 80% of those buildings were retrofit. So not only were 125,000 people left homeless due to a lot of soft story building collapses, it did give us a real test to see how those buildings that were retrofit were performed. So the ordinance today is really a reflection of the retrofit program that was started in the 70s on government buildings and bridges. And it was created by the Federal Emergency Management Agency. So a lot of people think that the cities are creating these engineering guidelines and ordinances, but they're really created with the Federal Emergency Management Agency with the assistance of the Structural Engineers Association of Southern California. We do have mandatory retrofit ordinances, but any city is going to follow the same exact guidelines. So if you have an engineer working in Los Angeles, West Hollywood, they're all going to be doing the same type of engineering. It's just going to depend on the city's submission and really fees and things like that. So you can go on our website to our resources page, and we have every city listed there with mandatory ordinances. So if you're not sure if one of your buildings is on the list, we have links to all of the cities' lists here. So what makes these buildings soft? So they were built with only a gravity system and no lateral. So they're going to have shallow pad footings and then a weak connection to the column to the beam. We've actually seen buildings where the column and beam are just sitting. There's no connection at all. It's pretty crazy when you start taking the stucco off what you find. There's going to be small pipe columns, so inadequate sliding resistance, which we'll talk about in a minute. And then the top level is going to be more stiff than the bottom, which makes it heavier, and that lateral motion could cause collapse. And garage doors do not add any structural value, so a lot of people will call us and say, hey, my building isn't soft, and we'll go look and have to let people know that garage doors don't add any element of structural value. When we look at a building, we always do a stiffness test before we send out any type of bid. So we're going to measure between the windows on the top floor and the bottom floor, and we're going to measure between the ground and the beam here. So we're going to get 80 inches. We're going to divide that by 2 and get 40. That number is a loose number of what numbers on top give enough shear resistance to give lateral support for that building. So we're going to take every number that isn't over 40 out, and we're going to add them together on the top and the bottom. So on the top level, we're going to get 190. On the bottom, we're going to get 92. And so if we divide that 92 by 190, we're going to get 48%. And this building is soft. So anything under 80% is a weak story. Anything under 50% is a soft story. You hear people talk about a line, it's the side of the building. So just moving forward, you know what I'm talking about? So the top building is the one we just looked at. The next one looks the same, but it has a window missing. So this one is not soft. On the next building, has no parking area, but it has more windows on the bottom. So none of these numbers are really over 40 inches, so that building is soft as well. So it just kind of depends on the engineer you're working with to, really know the lines that they're talking about to give you an accurate bid. So elements used to retrofit. So all the elements that are used work together as a system to send the energy back into the foundation and into the ground. So you can't really ask how much would this cost because there are multiple elements that are used to work together as a system. So a moment frame is very commonly used, and it's going to sit into the ground, usually on top of a pad footing with a grade beam through it. It's going to have really a rigid connection up in the corner and is going to be set down into the grade beam. So the next element is going to be a grade beam. So that's what we talked about on what the buildings are missing. So this is going to connect the vertical members to create that kind of frame. It's kind of creating a wall. And then it's also going to create sliding resistance. So those columns aren't going to go sliding when there's an earthquake. And it's made of rebar and high pressure concrete. Cantilever columns are really great. They're versatile. You can use them in two directions. If you use an HSS, which is a square column, otherwise you can use a built-up column. A lot of engineers don't like this method, but it is a good way to be cost-effective and save money during construction. So it just depends if that's something that you wanted to work towards. Maybe ask the engineer if that's something they'd be willing to design for you. This is an example of it going two directions. And then the pad footings will be enlarged. So most pad footings are only like 24 by 24 and like maybe 12 inches. And so we're going to enlarge those so that they really anchor that column down. And they're going to have anchor bolts as well that's going to hold them, and then Nelson studs, which are welded to the side of the column. And all this is actually in that really cool book that you got. So a drag system is going to connect those elements across. And this is the reason that you don't need something on every single bay, because that's going to drag that force across the building and send it back into that column and foundation. So most commonly it's a steel plate with STS screws, and then it's going to also have a system of clips. Just to give you an idea of cost, these need to be nailed every so many inches depending on the engineer's plan. And then a shear wall. Everyone always asks about shear walls and they think they're more cost effective. To me, shear wall means change order. You could have dry rot, you could have termite damage. If the pad footing that's existing that they're asking to dowel into isn't large enough, we're going to have to underpin. And so those are field changes that your engineer is going to do more engineering, and it's most likely going to cost more from your contractor as well. So if you have an option between doing a shear wall or a cantilever column, I always would push towards the cantilever column, unless there's no space. And it's going to have that drag system all the way down and connected to the existing foundation. And then sheathing. So when there's like an overhang of the building, we call that a cantilever. So if it's longer than 4 feet, we'll sheathe, which is blocking between the joists, and then structural plywood over top of that. And there's special nailing patterns, and that needs a deputy, and we'll talk about what a deputy is in a second. So a real life example of how this system would work. So our bully, the earthquake here, is going to give this guy a shove, and he's got a small pipe column. He's not into the ground, so he's going to fall over. So we're going to try that again, but this time we're going to give him a moment frame. We're going to plant his feet in the ground, and she's going to give him a shove again, and he doesn't fall over. But then we're going to add his friend here in the yellow. This friend is a small pipe column down the line on the building, and their arms are their drag system attaching them. So that bully is going to give a shove again, and that moment frame supports the whole system. So it's kind of a real life example. Starting with an engineer of record is whoever is stamping the plans. They're essentially liable, so they have to be on the Department of Consumer Affairs website. You can check here to see their license. Make sure you've talked to this engineer and that they're going to be involved in your project, that they're going to go to your site. There are a few companies out there that are design engineers that have somebody, in a different city stamping their plans, and it's just not the way to do it. And if you ever get into trouble, you're only going to have that company and you have no contact with that other engineer that's stamping your plans. You're going to need an engineer for the entire project. So during construction, the engineer needs to come to the job site and give structural engineering reports. Ask for references of projects that they've done. You can look them up on LADBS's website. You can see when it was submitted and when it was approved. So these people picked up on the 27th, and it was approved by December 19th. And if you think about this, that's, 2 months to get your plans approved once they're at the city. But you really need to look at when they were picked up and when they were approved, because they're going to have to go back several times sometimes for corrections with that plan check meeting before they're approved. And then ask what contractors they work with. For engineers, I wouldn't call a property owner and say, hey, how is your engineer? Because they don't know. I would call the contractors that they've worked with, make sure that they've showed up for their structural observations, and make sure that their design was easy to read and that they were workable if there was a field change during the construction project. And make sure you know who is going to be doing the observations. If they're going to assign one of their juniors to come look at the design during construction, just know that they're going to show up and not just ask the contractor, yeah, just send me a picture. So the engineer is going to come to your site, they're going to do as-built drawings, and then they're going to create the calculations and design, and then they're going to create the structural drawings. So once the structural drawings are done, they'll submit that with the calculation package to the city. The city is going to review that plan, and then the engineer will pick it up. They'll address any corrections and then return to plan check. They'll do this until that plan is approved in RTI. And RTI means ready to issue permit. Structural observations, these are the structural observations needed for a retrofit project. And most engineers will charge $350 per visit. I would ask the engineer if they could combine some of them. So if they can come look at the groundwork and steel in the same visit, could they charge you just one fee? That's a really great way to save some costs on this project. And field changes, find out if there's a field change during construction. Maybe there's an existing grade beam and that column needs to be moved out and the city inspector is asking for a detail change. Is the engineer going to include that in his original price, or is that going to be an hourly fee? Just find that out before signing with an engineer. And a release is okay to sign at the end to say you've picked up your plans, but I would highly recommend that it doesn't say that it indemnifies the company. You're basically saying that I'm happy with my plan and no matter what happens, I can never take legal action against you. And I don't know why you would need that sign, but it is something that is happening. And a designation of observer is if the engineer wants another engineer to observe his plan, you need that form signed by the existing engineer to say that they're okay with another engineer doing their observations. So choosing a contractor, get a PDF from your engineer, and that's easiest because if you have the paper copy, it's really hard to send that out for bid. First, you're going to check their license. So go to CSLB, type in their license number. It'll pop up with their license. Make sure that it's active and that they have this B, general building contractor. You have to be a general building contractor for retrofitting. And then make sure that their bond is up to date. A bond is going to protect you, so if they run out of money to finish your project, that bond is for you in your protection. Bond of a qualifying individual. So I'm the qualifying individual on our license. It means that I'm the licensed contractor that has the experience, that took the test, and am supporting our license. And then on that same page before was the workers' comp. So you can see if they have workers' compensation filed with the license board. And then you can click the personnel list and see who else is active on their license. If you haven't talked to any of the people that you've seen on their license, I would ask to speak to them, and if they can't produce them, I would be very wary about using that company. Insurances, the contractor should have at least a $1 million per occurrence and a $2 million aggregate policy. And you can call their insurance agent and make sure that they have insurance for retrofitting. It's actually a little bit more expensive, and if you don't have it and something happens on your site, your contractor's not covered, and then you could still be liable. And you can ask for a certificate of insurance as well, which getting that certificate, if they lose coverage anytime during your project, you'll be notified. So, and ask them for a list of retrofit projects completed. I would highly recommend going by job sites that are under construction. If it's finished, I mean, everybody has a different type of finish. Stucco work looks different. Make sure they painted it to look the same. And check out the permit status of past projects. You can actually see the inspection history if you go to LADBS's website. So you can see this project was started on, this is the same project from before, October 2017, and it was finalized 30 days later almost. So very quick project. That was one of the projects we did on Hollywood on Barton Street. And of course things happen. So if you see something where it's like maybe a lapse in time, say, hey, I noticed on this project there's a lapse for a month between your pre-inspection meeting and your next inspection. And maybe there was a detail change and they had to wait on the engineer. So don't chalk it all up to that. And then plan check and building permits differ by city, municipality. They start around $500 in Los Angeles, and I know in West Hollywood, the last building permit we pulled was $2,800. And we have a client in Santa Monica whose building fees for engineering and construction are up to around $5,500 right now. So huge difference. So deputy is a third-party inspector. They don't work for the contractor and they don't work for the city. They work for you. So they're there to make sure that the contractor is doing everything to specifications. You are welcome to choose your own. We have a list of deputy inspectors on our website, the city's approved list. And structural observations, we talked about those already. Any project with a valuation over $10,000, which is definitely going to be any retrofit, needs to have seismic shutoff valves installed and permitted. So sometimes people's handyman will do them and not permit them. Or a plumber will do them and not permit them. We can definitely help you with this if that's the issue, but we recommend not installing them until concrete is installed or poured. And the reason for that is any shaking of the building, that's going to shut the gas off to the tenant's unit. And then you're going to have to turn it back on and go light their pilot light. Stucco and paint, there are contractors who will get this concrete in the ground, the steel is in, and they go, see you later, finish your project on your own. Stucco is a huge cost of the job. Lath is one of the steps that needs a city inspection, so it needs to make sure that the paper's lapped correctly, and so I would make sure that your contractor does stucco and paint at the end. We have this really nice worksheet in the book that we gave you. And this is going to be a comparison worksheet. So the top's the project information about the building. The next is the contractor questions. If you don't answer yes to every single one of these questions, I would move on and get a different bid. So contract and job total costs. So their total cost of the contract, and then any extras that would be on the project. If they include it, just put an X and don't include it in your calculation. So this $52,000 project actually ends up being, with shutoff valves and everything to the end, $61,315. The next project we're going to look at, this is the same project we're looking at with two different bids. We included all of these items. They didn't include any of these items. So their contract actually ended up being more because they didn't include any of the stucco and paint and tenant paperwork. So make sure you really look at those extra fees. Tenant habitability plans. So, housing paperwork. I'm sure that everybody's advertising, we do the THP. A lot of people will submit the THP for you. It's online, it takes about 10 minutes. The part that isn't easy is knowing how to answer the questions correctly. So that's where we come in, and they've really shortened the THP in LA to be very quick online. It used to be about an 8-page process, but it does need to be served to tenants in a legal manner. So it needs to be personally served, posted and mailed, which is what we do, and use a service agency. So unless you're going to do one of these items, make sure that the contractor that you're hiring is going to do one of these things to protect you later. Tenant relocation requests. The City of Los Angeles makes us give out this worksheet that says, request for permanent relocation. And they're gonna see this $8,000 right here, and they're gonna say, I'll move. Otherwise, we have a letter that just says we're not offering relocation at this time, and you can move on. And then tenant appeals. Tenants have 15 days to appeal the tenant habitability plan. I've been to 5 hearings myself and listened to tenants. It just delays the project by like 3 to 4 weeks. And then cost recovery. The only city offering any recoup from tenants for the retrofit is Los Angeles, unfortunately. And the cost recovery program, you must turn in every invoice, canceled check, anything to do with the project that you spent money. We do a really great job of putting together a packet with like a table of contents for the city, and we do include that in our price. If it's something that you want to do and maybe the person that you worked with didn't offer, give us a call. We can definitely help you with it. We're here to help. We can just give you a worksheet to help you out. And then tenants, we do trench covers and signage as well. 2 projects I walked by, and they leave the dirt and debris on the site. The concrete's been poured on the top project, and that dirt and debris is still sitting there. It's probably been sitting there for 3 months. But if you have to remove it anyways, I say, just take it off the day that you take it out of the trench. There's no reason to have your job looking like this. The only time we've ever kept dirt is because we had to backfill it on top because there was a sewer line, and so we had to go deeper for the grade beam, and so we kept the dirt to put back over top of that at the end. So this one has 8 cantilever columns and sheathing and a drag system. So this project we walked by was actually, we would price at like $148,000. If we did it again with re-engineering, with a moment frame, a grade beam, a drag system, and sheathing, $70,000. This happens quite a bit. Kevin and I got a plan from a client of ours, and I go to the job site every single time I get sent a plan. I never just bid off of a plan without going to the job site. And you should actually meet the contractor that's bidding on the plan at the site and have them explain the plan to you. So that, you know, if you have 3 different contractors bidding on your plan, they should all have the same story, right? They're looking at the same plan. Maybe one of them missed the sheathing and their bid is much lower. They're either gonna run out of money or they're gonna come back and ask you for more money. So Kevin and I went to the site, and I was like, what's behind these doors? And I opened them up. It was the electrical panel. So they had a shear wall that was unnecessary. We walked down, and I looked up, and I said, Kevin, how big do you think that cantilever is right there? And he goes, looks like 3, maybe 4 feet. We measured the windows, and I called Mo, and I said, hey, can you do a calculation for me quick? Nope, not soft. Didn't need that cantilever column. We re-engineered it, and with the construction, we saved her around $35,000. So it's always good to make sure the contractor that's bidding on the plan goes to the site before you get the bid. If you don't retrofit and you're within your deadline, I don't have to retrofit for 5 years, 7 years. There's an earthquake, your building collapses. You could still be seen as negligent if you didn't get your engineering started or any start at all. In 2003 in Paso Robles, this building collapsed on these 2 women working at a clothing store, and the families were awarded $2 million. And so you can let your tenants know that there's retrofit, and also get your engineering started to help reduce your liability on something like that happening. And then if the deadline does pass and you haven't retrofit, your insurance company is going to first drop your policy, which honestly some of them are dropping them even if you're not within the timeline. And then you're not going to be able to use it for a loan. You're going to get a misdemeanor from the city, and then you could essentially have your building red tagged and it will be demolished. And you will not lose any parking spaces. The way the ordinance is written, we have to keep all legal permitted parking spaces. And tenants do not need to relocate. Your tenants' rents only in Los Angeles can be raised to pay for retrofitting. And I get asked a lot, well, what if my tenant moves out and I can't raise the next tenant's rent $38? You can raise the next tenant rent as much as you want, thanks to that ordinance not passing, that proposition. And financing programs. So property assessed clean energy financing can be used for retrofitting. The rates are around 7% though, so I think you'd probably have more luck with a traditional bank loan or refinancing. And I have one more thing to add. A contractor cannot ask for more than $1,000 at signing of your contract. It is against the law. You see that a lot.